Hi everyone, let's go ahead and do a quick review of the final exam. So what I'm gonna do, I'm gonna give you sufficient information for each of these problems so that you can work on them on your own. Okay, I don't intend to do it line by line and give you a final answer. However, I will give you sufficient information so that you can work on it on your own and finish the work. Okay, so if you watch the video, you should pretty much get the whole thing, and I don't see any, or I don't foresee any issues. Just make sure that you follow the steps that I'm recommending for each of the problems. All right, let's get started with problem number 1, weighted mean. So this is what it is, and the formula for weighted mean is this. If I were to write it out, this is how it's gonna look like. So you're gonna write it as W1 x1 plus W2 x2 plus dot 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 plus Wn xn, and in the bottom summation of Wi, so which is going to be W1 plus W2 plus dot 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 plus Wn. Okay, now in this problem excuse me, in this problem what you have is this. Your grade in the class consists of 2 midterms, right? 15% each, and homework, project, etc., etc. So midterm 1 is what you got, 85, right? Your score is 85. However, midterm 1 is gonna be 15% of the total grade. So you'll take 85, okay? That's your xi or x1, you can think of it that way, multiplied by 0.15. And similarly for midterm 2 is going to be 90 times 0.15. Final exam 80 times, what is the weight for final exam? Final is 30%, so 80 times 0.30. Homework 95 times homework is 10%, 0.10. Project is 5%, 100 times 0.05. And participation is 10%, so it's going to be 75 times 0.10. So you will have to add up all these numbers, and whatever number you get, you have to divide everything by the sum of the weights. Remember, these weights may not add up to 1 or 100%, so you may have to do it 0.15 plus 0.15 plus 0.30 plus 0.10 plus 0.05 plus 0.10. Okay, so this is the process, and after doing this, whatever answer you get, that's your answer, that's your weighted mean. Make sure that I did not miss anything, any of the categories, but you get the idea. This is what you should be doing. Okay, now in this problem you're going to be doing bar chart. So these are categorical data, different numbers of gyms in Salinas. So you just have to create the categories and put it along the horizontal line. So Salinas, okay, Monterey, Marina, and let's say, and so on and so forth. You do it, and then for Salinas you have 10 gyms. So let's say that's your height, okay. And you create a rectangle like this, and for Monterey you have 3, so you do, oops, maybe 3 would be something like this. Marina has 2, maybe something like this, and so on and so forth. So this is gonna be categorical data. So for each of these cities you do the corresponding height of the bar. So that's how you do this problem. For stem and leaf, pretty standard. So you just need to categorize these numbers. What you're gonna do, you're gonna look at tens. So the numbers that start with 1, okay, or ones. So ones, twos, threes, fours, fives, and I don't know if it goes to 6. If it does, do I see anything in the 60s? Okay, yeah, it does go to 6. So let's it's good to do it in one column. And what you need to do, you look at the numbers that have 1 as a starting digit. So you have 18, then you have 19, another 18, 17, 18, 15, and let's see, did I miss anything? Looks like I got all these things. So smallest is 15, so give it a little space, 5, and then you have 7, then for 18 you have 3, so you put 8 3 times, okay, and for 19 you have 1. So that's how you do this. Now you do the same process, you repeat the same process for 2s, 3s, 4s, 5s, and 6s. By the way, in the exam I'm not gonna be giving you something like this big. This is for practice purposes only, okay? In the exam, if I give you something with stem and leaf plot, it will be something simple, okay, with smaller set of numbers. But in reality, you will ever hardly do it by hand. What you will do, you will use some sort of software, and it's gonna do it automatically for you. I just wanted to give you a flavor of it, okay? Hopefully this problem will be okay for you. Now you can continue and finish it off right here. Now for creating histogram, for this one, create a histogram with 5 classes. The best way to do it is this. Just look at the lowest data point. In this case I see 0, the lowest or smallest data point, and highest data point is 10, right? So highest minus lowest is what? 10 minus 0, which is just 10, right? Then you take this number, that's the range of the data points, correct? And divide it by the number of classes. So 10 divided by 5 is equal to 2. So your width for each of these classes is going to be 2. So you start off at the smallest number, which was 0, right? So 0, 2, 4, 6, 8, and 10, okay? Now, how many numbers are between 0 and 2? The convention I'm going to follow here is that, so the boundary point 2, I'm going to kick it into the next class, okay? I'm not going to include it into the first class. So 2 is going to be in the second class, 4 is going to be in the third class. However, for the very last class, I will include it here, okay? All right, so let's go ahead and do it and see how many numbers are there between 0 and 2, excluding 2. So let's see, 1, 2, 3, 4. So let's see, 1, 2, 3, 4. So you make this height to be 4. Let's say this is my height 4, okay? Then between 2 and 4, excluding 4, how many numbers do I got? So excluding 4, so 3 is there, 1, 2 is there, and I think that's all. All right, so there are just 2 of them. Oops. So that's what it is. Now between 4 and 6, how many are there? Excluding 6, of course, so 5 is there, 4 is there, and 5, 4, yeah, looks like 2 of them, so it's gonna be just 2, and you continue doing it for this and these classes. That's what you do. Pretty straightforward, nothing really complicated. So for this one, what we are gonna do, we are going to find the mean, median, mode, percentile, quartile, etc. So for this data set. Now mean is the average, or the sample average. The symbol for it is x bar. So what you're going to do, you're going to add up all these numbers, 9 plus 1 plus 5 plus 3 plus ... all the way up to plus negative 5 plus -3 plus 12, right? And divided by the total number of data points. Honestly, I don't know how many of them are there. So let's say there are 20 of them. I just made up that number. Make sure that you check it. So I'll just put n, where n is total number of data points. Okay, that's how you'd find the mean. Median, to find the median, what do? You need to order these data points. Okay, you need to order it from smallest to the largest, or in ascending order. All right, the smallest data point I see is -5, so it's going to be -5, and then probably -3, and all the way up to the highest data point I see is 31. Then you find the middle. Now, if there are odd number of data points, middle is precisely defined, right? What is the middle data point? If there are 5 data points, let's say 1, 2, 3, 4, 5, the middle data point is going to be here, right? However, if there are 6 data points, then what do? You add the middle 2 and divide it by 2. Okay, divide it by 2. And mode is going to be basically the most frequently appearing data point. You look at the data set and which data point appears the most, or most frequently occurring data point. In this case, you just have to see which ones are. I kind of see that 8 here appeared 3 times. If there is anything else, you could go ahead and look at it and find it. All right. Sometimes you may have more than one mode. So if you have 2 modes, we call it bimodal. If you have 3 modes, we call it trimodal or multimodal. So just look at these data points and see which numbers appear maximum number of times. Okay, I see that 8 appears 3 times. There might be some other numbers appearing 3 or more times. Remember, the number or the data point that appears the maximum number of times, that's your mode. Now, percentile. So for percentile, this is what you do. So first of all, you need to order the data points. So you'd order them like this: -5, -3, and so on and so forth, all the way up to, let's say, 31, the highest data point. Now, what you want to do is this: count the number of data points. Okay, so in this case, I didn't count it, so let's say that number of data points is n. Okay, n is the number of data points in this data set. Once you know that, so let's say you want to find the 25th percentile, okay, which is the first quartile. So 25th percentile is what? 0.25, correct? 0.25 times the number of data points. And let's say you will get a number, okay? Let's say you get, I don't know, 4.3. What you'd want to do here is this. This number, if it happens to be a fraction, you want to round it up, okay? You want to round it up to the next number, that means which is going to be 5. Now, in the ordered data set, right here, in the ordered data set, you go from the beginning, 1, 2, 3, 4, 5, or 5th position. Data point at the 5th position would be your 25th percentile. Now, if you want to find out 75th percentile or 65th percentile, doesn't matter. You just replace this 0.25 by the corresponding percentage. And then, if the number is fraction, you round it up. I think there are a couple of ways of calculating these percentiles. So there is not a standard or universally accepted method. But what I'm following is that if you see a fraction, just round it up always. Okay, even though, don't think of it as rounding a number. Like if you have 4.3, if you had to round it to the closest integer, you would round it down to what? 4, right? Or on the other hand, if you had 4.6, if you had to round it to the closest integer, you'd round it up to 5. But in this case, in the case of percentile, you always round it to the next number, even though if it were to be something like 4.1 or something like that, you'd always round it up to the next. So this rounding for regular numbers is not the same as rounding for this guy, for percentiles and quartiles. Now, what is interquartile range, which is the third quartile minus the first quartile? Okay, so that's what you would do. You'd find the data point for the third quartile and data point for the first quartile and subtract. That's it. Third quartile is 75th percentile, so you'd replace this 25 by 75. Now the next one is this 5-number summary and the box plot. So there is a 5-number summary for percentiles and quartiles. So the minimum, maximum, Q1 is the first quartile, Q2 is the mid quartile or second quartile or median, and Q3 is the third quartile. So you should be able to find these numbers from the data set. Once again, in real world, you'll never do it by hand. However, I'm making you do it by hand so that you get a feel for the things, okay? Instead of just using a calculator or some software, you just do it mechanically. Just do it for this data set and you should be fine. Next is the empirical rule. Remember, the empirical rule says it applies to bell-shaped curve, okay? So if you have bell-shaped curve, so that's your mean. If you move 1 standard deviation to the right and 1 to the left, so you're going to be moving x bar plus s. You're going to be moving x bar minus s. In between, this is going to be about 68% of the total data point. As you know right now, since you have seen more advanced things, it's actually about 68.2% of the total data set. But I'm okay with 68%. What can you say about the number of people who make more than $57,000? Okay, they tell you somewhere, oh, it's empirical rule, so they tell you that it's bell-shaped. So 57,000. So given that 48,000 is the mean, so your x bar is 48K, and 57 would be somewhere to the right. As it turns out, this is exactly 1 standard deviation to the right. So because 48 plus 9 is 57, so this is 57. So they're asking you to find out this area, okay? As you know by now, probably, this is basically the probability. So probability that x is greater than 57K or 57,000. Now, this is 68%, right? So outside must be 100 minus 68 because all the area under the curve is 100%. So all the area under this normal distribution should add up to 100%. And so it's going to be 100 minus 68, right, percent is going to be equal to 32%, right? Now, that 32% is going to be divided between right and the left. So this is going to be 16% and this is going to be 16% roughly. So to the right, this black shaded region is going to be 16% of the total. So 16% of the total. Now, how many people have you surveyed? 200. So 16% of 200. That's what you expect, which is 16 over 100 times 200, and which is approximately 32. Okay, that's what it is. Similarly, you do how many people make between 39 and 66. So to get to 39, how many standard deviations do you move to the left? As it turns out, 48 minus 9 is 39. So here, so it's going to be 39K. Now for 66, let me just draw something here. That'll be easier for you to see. So this is your 48K. To get to 39, you move 1 standard deviation, 39K, right? Okay. To get to 66, remember, you'll be moving 2. 1 standard deviation is going to take you to 57K, and another standard deviation 57 plus 9. 48 plus 9 is 57. 57 plus 9 is 66. So you're moving in essence 2 standard deviations, right? Now from your previous knowledge, you know that this green shaded region is what? 68%, right? Now you just need to find this red shaded region. Excuse me. Now you also know that if you move 2 standard deviations to the right and 2 to the left, so let's say 30, okay, you include about 95% of the data, right? So 95% means what? So the middle green portion is 68%, right? So 95 minus 68%, which is, by the way, what is it? 27%. 27%. That 27% is going to be this red shaded region and this unshaded region, okay? Now they are equally distributed, so half of that is going to be this red shaded region on the right, so which is 13.5%. So your interest is actually this entire thing from here to here. You don't really care so much about this, right? You are not interested in that as much. So it's going to be 68% plus 13.5%, all right? And if you add this, is probably 81.5% of the total, which is what? 200, right? So that's what it is. So simplify it, that's your final answer. Now in this problem, what you're going to do, you're going to use Chebyshev's rule. Remember, here the assumption is that you don't know anything about the distribution, right? And the Chebyshev's rule says that you include approximately this percent of the data, this proportion of the data, okay? 1 over 1 minus k square. K is the number of standard deviations you move from the mean. Now remember, this only works for k greater than 1. So k has to be greater than 1. If k is less than 1, it's not going to work. So again, you take the sample of 200 people. This time, they do not tell you that it is bell-shaped. So you really cannot make any assumption about the population shape or distribution. Assume that you take blah, 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 and they are okay, standard deviation. So now let's see, what can I say? What can you say about the number of people who make between this and that? So here, what can you say about the number of people who make between 25,500 and 70,500? Now, just see how many standard deviations are you moving from the mean. The easy way to find it is this, kind of like you know it by now. I'm not going to use the Z, I'm rather going to use K. Remember, the letter Z is reserved for bell shape. So to avoid confusion, I'm going to use K. That's why I guess they use K here as well. So it's going to be 25,500 minus 48,000, all of it divided by 9,000. Okay, and I think, if I recall correctly, it's negative 2.5. And similarly, you can check for 70,500. K is going to be positive 2.5. That's how I designed the problem. 70,500 minus 48,000, all of it divided by 9,000. That's going to be 2.5. Now, your K is 2.5. By the way, it really doesn't matter what the sign of K is. Just make sure that one is positive, one is negative, then you are okay. So your answer is going to be 1 minus 1 over 2.5. Since it's getting squared, it doesn't matter whether 2.5 is positive or negative. Okay. And that's going to be 1 minus 1 over 6.25. And you can simplify it, you're going to get a number, which is going to be a fraction by the, yeah, of course, a fraction between 0 and 1. Now, what do you want to do? You want to take that number and multiply it by 200, okay? Because that's how many you surveyed. So you can say at least that many people make between, so this number times this, at least that many people make between 25,500 and 70,500. Now the next problem is kind of interesting. The same thing. What can you say about the number of people who make more than 70,500? We don't need to make the calculations again. We know that k is gonna be what? 2.5, right? So the distribution is some weird shape, I don't know. Okay, let's say that's your x bar. Now you go 2.5 standard deviations to the right, 2.5, right? So outside, so more than, that means you're looking for this. Now in the last problem you found, let's say, I don't know what the exact number is, let's say at least 150 people make between 25,500 and 70,500, at least. So at least this is the calculation you got. Excuse me, this is the calculation you got from the last one, right? For this problem you really don't have to do anything new calculation wise. It's just conceptual understanding. Now look here, what's happening is this: at least 150, let's say 2.5 standard deviation times 2.5 times s, which is like 70,500, right? And let's say here, which was 25,500. In between, at least 150, meaning outside, which is either here or here, could be at most 200 minus 150, which is 50. Okay, where do I get that number from? 200 is the total number I surveyed, and 150 is at least in the middle part. So outside would be at most 50. Okay, now this is not bell shape, it's some arbitrary shape, correct? Now you cannot make the assumption that out of that 50, 25 is going to be to the right and 25 is going to be to the left. No, it could be the case all of 50 is here, or it could be the case none of 50 is here in extreme cases, or it could be the case 10 of them are here, 40 of them are here, or any other combination, okay, or 30 of them here or 20 of them here. So there is no uniform distribution between the two tails. Okay, so what you are going to say that at most, the best you can say is that at most 50 people make more than what? 70,500. That's the best you can say. In this problem, you kind of have to use this formula: probability of A or B, or sometimes you write it as probability of A union B, is equal to probability of A plus probability of B minus the probability of A and B. All right. So this is also the same probability A plus probability of B minus probability of A and B. Okay. Is there a problem because the probabilities do not add up to 100%? No. Think of what could happen when you are taking two classes. All right. Let's say this is, let me make it look a bit more nicer. Okay, this is your S for statistics, and this is your OC for OChem, organic chemistry. Statistics class, okay, 80% chance that your chances of passing statistics, okay, 70% for organic. The probability that you pass both classes is 55%. So this is going to be 0.55. Okay, so the middle overlapping part. So what is the probability that you pass only statistics. In that case, it's going to be, you know, overall probability for passing statistics is 80. So if the middle part is 55, the left part where you only pass statistics is going to be 80 minus 55, which is 0.25. Okay. And similarly for chemistry, middle part is 55, right? The probability that you pass chemistry is 70%. So the right part is going to be the probability that you pass only chemistry, and which is what, 70 minus 55 is 15. So these are the three things. There is one more thing that could happen, that you fail both of them, then you are outside of these circles, what we call Venn diagram, right? In this case, what I'm going to do is this. So look, add up these numbers. All right. So 25, 0.25, 0.55, and 0.15. 0.25 plus 0.55 is 60, 80, plus 0.15 is 95. So you have 95% chance that you pass both of these classes, or one class or the other. Okay. Then 100 minus 95, or 1 minus 0.95 is 5%, right, or 0.05. So you have a 0.05 chance that you fail both of these classes. So all of this could happen here. Now this is sort of like, think of it this way, that would really help you understand. Statistics, OChem, all right. What could happen in this world of statistics and OChem? A student who takes statistics and OChem, this is all that can happen. You pass statistics, pass OChem. You pass statistics, you fail OChem. You fail statistics, you pass OChem. You fail statistics, you fail OChem. These are all the events that could happen. So that is your sample space. All the possibilities, all the possible simple events. Okay? That's your sample space. Nothing else could happen, right? So you just look. This is, if this happens, you are passing statistics, failing OChem. Passing statistics, failing OChem. Okay? That's 0.25. Passing both, that's 0.55, the middle one, right? So it's going to be 0.55 here, 0.25 here. Failing statistics, passing OChem is going to be 0.15. And failing both of these guys, that means you're outside of this Venn diagram in the universe of 2 class. Okay, which is 0.05. All of these should add up to 1. Remember, sum of all the probabilities must add up to 1, kind of like probability of the sample space, S sample space is always 1, right? So, is there a problem? No, there is not a problem. Create a Venn diagram, yes. Find the probability that you pass stats. Oh, I gave it out to you. Probability that you pass stats is 0.25, and based on this, you can keep going and answer everything. Probability that, so let's see what else is there done. What is the probability that you pass one of the 2 classes? So one of the 2 classes, so look, one of the 2 classes is going to be what? Either pass statistics or this. So it's going to be 0.25 plus 0.15, okay, which is 0.40. And if you understood this diagram, you should be able to answer the rest of the questions. Now let's go ahead and do this problem. What is going on here? You roll a die. Your possible outcomes are 1, 2, 3, 4, 5, or 6, right? And we define 2 events in this context. A is this 2, 4, 5, and 6, and B is 1, 3, 4, and 5. Is the event simple or compound, these events? Remember, the definition of simple events is that an event is simple if it can happen in only one way. Okay, there is only one way you can happen, the event can happen. However, here the event A, it can happen in multiple ways. As a matter of fact, if you roll a die, if 2 shows up, then event A has happened. If 4 shows up, event A has happened. If 5 shows up, event A has happened. If 6 shows up, event A has happened. So this is really not a simple event, okay? And similarly B. Are the events disjoint? Remember, 2 events are disjoint if their intersection A and B is empty set. But in this case, is there anything common? Yes, there is one thing common between them. Okay, so A intersection B is 4, right? Is there anything else common? No. Oh, 5 is common too. Sorry, I missed 5. So 4 comma 5. So this is not disjoint. Find the probability of A. A will happen if these guys show up, right? So it's going to be probability of A is going to be, remember, A can happen in 4 different ways, correct? So if one of those 4 numbers show up, then you will see that event A has happened. So the probability of that happening is 4 out of 6, because there are 6 possible outcomes, right? And there are 4 possible outcomes that is included in event A. And similarly, you can find for event B, A union B, that means you find the A union of these 2 events, right? A union B, you will see it's 1, 2, 3, 4, 5, 6. Okay, so what is the probability of A union B? If you roll a die, outcome has to be one of the numbers 1 through 6 integers, right? 1, 2, 3, 4, 5, or 6. So the probability of this is going to be 1, and probability of this is going to be 2 over 6. Why is it 2 over 6? We just found that intersection of A and B is 4 comma 5, right? There are 2 possibilities out of 6. A complement means what is not in A. So A prime is a complement. So let's see what is in A. In A is 2, 4, 5, 6. So 2, 4, 5, 6. A is 2, 4, 5, 6. 2, 4, 5, 6, right? A complement must be what is not in A. What is not in A? 1 and 3, right? So what is the probability of A prime, which is 2 out of 6. Similarly, B prime. Similarly, you find A prime and B prime. You do the union of them and see what you get, okay? All right, so that takes care of this problem. And let's do the next problem. Again, my events A and B are this. I define these 2 events. So what do they want you to find out? Independent and dependent are mutually exclusive / disjoint. 2 events are independent if probability of A is the same as probability of A given that some other event has happened, right? So probability of event A is the same as the probability of event A given that something else, B, has happened. So that means just because B has happened, it has no bearing on A. So we can just use this thing. So, or by the way, it doesn't have to be only this way. You could say it this way: probability of B is the same as probability of B given that event A has happened. Now, what is the probability of event A? So let's use this one. That's probably slightly nicer looking. What is the probability of event B? Probability of event B is 2 out of 6. Why is it 2 out of 6? Because you have 2 and 5, right? 2 items in the set B. Now, what is the probability of B given that A has already happened? So first of all, probability of B given that A has already happened. Remember, this is just 1/3, right? Now, if A has happened, what do you have? 2, 4, or 6. If event A has happened, so this is something already has happened. If event A has happened, you know for sure that the number that showed up is either 2 or 4 or 6. Nothing else could be. If one of these 3 numbers have showed up, then you have event A. However, event A has happened. Now, if that is the case, how could event B happen? Look, what is common between event A and B? Just the 2, right? If event A has happened, only way B can happen is that if 2 is the number actually showed up. Okay? Event A could happen by 2 showing up, by 4 showing up, or by 6 showing up. But event B will also happen in addition to happening event A only if just 2 shows up. If 4 shows up or 6 shows up, event A has happened, but event B has not happened. Now, if event A has already happened, what are your chances of event B happening, which is 1 out of 3, because only if 2 showed up, that's when event A has happened and also event B has happened. So your probability is going to be 1 out of 3. So it looks good. Now you can check it the other way around too. For probability of A, so what is the probability of A? Oops, probability of A, which is 3 out of 6, right? 3 over 6, which is 1/2. Probability of A, given that B has happened, right? Now, given that B has happened, oh, what happened? The numbers are going to be either 2 or 5. Now, if we know for sure that B has happened, how could we find out? I mean, yeah, what is the probability that A will also happen? Look, A can only happen if 2 shows up, because the common number between A and B is 2. If 5 showed up, then no, it didn't work, right? B has happened, but A hasn't happened. So how many ways 2 can show up? If we know that 2 of these are outcomes, possible outcomes, 2 and 5 is going to be 1 out of 2. See, they are the same. Look, by the way, don't compare this one with this one, right? These are 2 different ways of showing the same thing, okay? This is one way, this is another way. You don't have to show both. And are those disjoint? No, there is something common between them. So probability of A intersection B is equal to probability of A intersection B is what? Just 2, right? Probability of 2 showing up, right? Which is 1 out of 6, obviously is not 0. So these events are not disjoint. Exactly the same way you do this one, okay? Let's go ahead. Excuse me, I'm a little under the weather. So quality control, so what is it? 2000 t-shirts came from Bangladesh, and you're the quality control manager. You want to make sure that your lot is good. If you find at least one t-shirt faulty, then you're going to reject it. How many do you collect? 5 of them. So you randomly select 5 t-shirts from a lot of 2000, and even if you find one t-shirt bad, then you're going to go ahead and reject the lot. So you have a strict rule. So from experience, you know that there are about 20 faulty t-shirts in a lot of 2000, okay? That's something you know from experience. So what is the probability that you will not reject the lot? That means, what is the probability that you find all 5 t-shirts by randomly selecting from a group of 2000, all of them are good, not bad, not a single one is bad. So the easy thing to do is this, right? Look, you can think of it as bunch of events. Event A1, event A2, event A3, event A4, event A5. A1 is the event that the first one you pick is good. Now, what is the probability that probability of A1 is that the probability that the first t-shirt is good. So the first t-shirt is good is it's not 20 out of 2000, by the way, a typical source of mistake. 20 out of 2000 is the probability that a t-shirt is bad, because there are 20 of them are approximately bad out of 2000. So if 20 of them are approximately bad in a group of 2000, how many are good? Is going to be 2000 minus 20, or 1980 of them are good, okay? These are good. So your probability of getting a good t-shirt in the first try is 1980 out of 2000. Now that you picked a t-shirt that's a good t-shirt, you really don't want to put it back. You put it on the side, okay? And that's pretty much what common sense would tell you, right? Because you found something and you put it back, then you let's say in theory you could get that one again, right? So let's put it aside. So that makes it sort of like a dependent probability. Okay, so these events are not independent really, these events are dependent. So second time around you're going to have 1979 approximately out of 2000, and you keep doing it for each of these. Okay, for the sake of calculation, these numbers, somehow one could argue that it's probably okay to just do it like this: 1980 over 2000, and raise it to the power 5 means you multiply it 5 times. Okay, so it's going to be 1980 over 2000 times 1980 over 2000, 1980 over 2000, and you do so for 5 times. Instead of reducing this, oops, I made a mistake here. This should be 1999, right? And then the next one should be 1978 over 1998, and I'll just write it out: 1977 over 1997. 1 2 3 4 1976 over 1996. So you multiply these numbers and that's your probability of getting all 5 good. But as I said, one could argue that, hey, let's use this number, which probably is going to be pretty close to this product of these numbers. So you can model it that way as well. That's what I'm trying to say. So this is a Bayes theorem problem. So let's go ahead and write down the Bayes formula or Bayes theorem, right? So it is probability of A given B is the same as probability of B given A times the probability of A, all of it divided by probability of B. Now this is the formula that we are going to be using. In this context, what is it they're looking for? You read the problem. As a quality control manager, you find a defective item, right? Now you need to analyze which one did it come from. I'm just going to label the events A, B, C, and D. A is the probability that it was produced or manufactured by plant A. B is the probability, B is the event, not probability. A is the event that it was manufactured by plant A. B is the event that it was manufactured by plant B, and C is the event that it was manufactured by plant C. And D is the event that you randomly select an item, it is defective. Okay, so these are the events. So as a quality control manager, you pick one item randomly, let's say, and you find that is defective. What are the chances that it came from each of these individual plants? Of course, the probability that it came from one of those 3 is 100%, right? But the moral of the problem is this: you find the probability that it came from A, plant A, you find the probability that it came from plant B, and you find the probability that it came from plant C. And out of these 3 probabilities, whichever is the highest, that's the one you probably think that is likely culprit. Okay, so now let's go ahead and do this. So let's see, what is it? So what we want to find out is this, by the way: probability of A given, probability that the item was manufactured by A, plant A, given that it is defective, because the manager picked an item and he found it defective, or she found it defective, right? And similarly, you would have to find probability of B, that means probability that plant B has produced it, given that it is defective. Probability that plant C has produced it, given that it is defective. I'm just going to do one of them for you. So if I use this formula, so it's going to be, I should have used a different symbol for it. This is the general way of expressing Bayes theorem, and this A and B happens to be coinciding with what we have used for symbols. I could have used this as A1 and A2. It would still be the same. So probability of A given D is going to be probability of A given D is equal to, divided by probability of D, on the top is going to be probability of D given A times the probability of A. Okay. Now let me find out these values. What is the probability that an item is defective? So that's the hard part for you guys. Probability that an item is defective. Remember, if an item is defective, it could come from plant A or plant B or plant C. So I could rephrase this probability as such as this. So probability of defective, okay, and A, right? Because it could be defective and coming from A, plus probability of being defective, probability of being defective and coming from B, plus the probability of being defective and coming from C. Now these probabilities are given to you. Also, A has 1% chance, right? So it's going to be 0.01 plus B has 2% chance, 0.02, plus C has 3% chance, 0.03. So this is going to be 0.06. So probability of a defective item is 0.06. So let me just do it here. Probability of A given D is equal to probability of D, which is 0.06, this number. Now what is the probability of defective given that it has come from it has come from A? So which we already kind of know, right? Defective and coming from A is going to be 0.01. Okay. If it comes from A, the probability that it is defective, so what is given, you have to kind of think of it that way. What is given? Given that it has been manufactured in plant A. Now what is the probability that it is defective? If it is manufactured in plant A, the defective probability is 1%, so that's why I write 0.01. Now what is the probability that the product has actually been manufactured in plant A? Remember, A manufactures 50%, so it's going to be 0.5. And similarly, you do it for probability of B given D, C given D. Just to let you know, all you have to do is just change these numbers, these two numbers. For the case of B, is going to be 2%, right? 0.02 times, the bottom doesn't change. 0.02 times 30%, 0.3. For the case of, so this is for B. And for the case of C, it is going to be 20% or 0.2 times 0.03. So I'm just going to write this one here, 0.03 times 0.2. And you can simplify it, and then you will see which number is greater. By the way, these two probabilities are going to be the same, just to give you a heads up. Now let me go ahead and pause here for this portion because looks like it's getting longer. I am almost at 1 hour mark for this video, so I may have to make another video for the remaining problems. So go ahead and watch this one, and there will be part 2 of final exam review. So let me stop here and I'll pick it up from that place, next problem, which is going to be permutation, I think. Is it permutation and combination? So I'll pick it up from here in the next video.